Hi everyone, my name is Jihi Luan, and this is my week one assignment for the course Statistics and Quantitative Methods at Tri University, instructed by Dr. Charles Ripley. Today, I'll be presenting a descriptive statistics analysis of a dataset containing hypothetical income data for 500 MBA graduates. The dataset includes each graduate's age at graduation, school type, business major, and income 5 years after graduation. Over the next several slides, I'll walk through measures of central tendency, measures of dispersion, and three data visualizations, and then connect each finding to real-world business implications. I will also acknowledge the limitations of this analysis throughout. So this slide presents the central tendency statistics for both income and age at graduation. Starting with income, the mean is $100,560. The median is $98,180, and the mode is $65,159. So the fact that the mean is higher than the median tells us the income distribution is slightly right skewed, which means a relatively small number of high-earning graduates are pulling the average upward. Because of this skew, the median is actually the more reliable measure of a typical MBA salary. The mode of $65,159 is notably lower than both, indicating that there is a cluster of graduates earning salaries at the lower end of the range, likely those entering fields with more modest starting compensation. For age, the mean is 30.9 years and median is 31. The mode is 28. These three values are closely aligned, which tells us the age distribution is nearly symmetric. Most graduates complete their MBA in their late 20s to early 30s, with 28 being the single most common graduation age. So, this slide addresses how spread out the salary data is. The standard deviation is $23,306, meaning that in a roughly normal distribution, most salaries fall within about $77,000 to $124,000 of the mean, which is a moderate but meaningful range. The variance of approximately $543 million is a square of the standard deviation and confirms this spread mathematically, though it is less intuitive to interpret directly. The range of $78,575 from a minimum of $61,370 to a maximum of $139,945 shows that outcomes vary dramatically across the sample. The interquartile range of $41,823 bounded by Q1 at $80,396 and Q3 at $122,219 captures the middle 50% of earners and is more resistant to the influence of extreme values. For age, the standard deviation is just 4.21 years over a range of 14 years, confirming that the cohort is tightly clustered. The low age variation actually strengthens our ability to make salary comparison across the group since age-driven differences are relatively small. The pie chart shows the distribution of MBA majors across 500 graduates. For majors, finance at 23.4% and management, accounting, and data analytics each at 23% are nearly equally represented, together accounting for over 92% of the sample. Economics is significantly underrepresented at just 7.6%, with only 38 graduates. This near equal split across the four major groups is actually important for statistical purposes because each group has roughly 115 observations, and any comparisons we draw between them in terms of salary outcomes are on equal footing and carry similar statistical reliability. The small economics subsample, however, means that any conclusions about economics graduates specifically should be treated with caution, with only 38 data points. The margin of error for that group is considerably higher than for the others. And the bar chart compares average income 5 years after graduation across the five majors. Economics majors lead the group with an average of $105,216, followed by finance at $103,862, and data analytics at under $3,255. Management graduates average $98,061, and accounting comes in lowest at $95,470. The total spread between the highest and lowest earning majors is approximately $10,000, modest relative to the overall mean of $100,560, but consistent with what we would expect from a diverse cohort entering a wide range of industries. The pattern aligns with broader market trends, which is majors requiring strong quantitative and analytical skills, such as economics, finance, and data analytics, tend to command slightly higher compensation. It is important to note that, however, that these averages do not control for employer industry, geographic location, or pre-MBA work experience, all of which could independently explain much of this variation. The scatter plot maps each of the 500 graduates by age at graduation on the x-axis and income 5 years later on the y-axis. What stands out immediately is the absence of any visible trend from age 24 through 38. The data points are distributed broadly and uniformly, with income spanning the full range of approximately $61,000 to $140,000 at virtually every age. There is no upward slope suggesting older graduates are more, nor any downward slope suggesting younger graduates do better. The correlation coefficient confirms that this near zero linear relationship. This is a meaningful finding for business because it suggests that MBA programs effectively equalize earning potential regardless of when a student enrolls. Employer evaluating MBA candidates should not make assumptions about a candidate's earning trajectory based on age at graduation. Other variables like major, industry sector, networking quality, and firm size are almost certainly stronger predictors of post-MBA income than age alone. These findings carry several direct implications for how businesses and individuals should think about MBA hiring and compensation. First, the median income of $98,180 provides a reliable salary benchmark for HR teams designing compensation structures for MBA level roles. It signals that the 5 year post MBA earning potential is reliably near six figures, which is useful both for recruitment marketing and for internal pay equity analysis. Second, the approximately $10,000 earning premium associated with economics and finance majors suggests that the firm competing for analytical skill talent, particularly in finance, strategy, and consulting, should expect and budget for higher compensation demands. Third, the near equal distribution across four major groups means that talent pipelines are balanced and predictable, which simplifies workforce planning for employers recruiting broadly for MBA programs. Fourth, and perhaps most actionably, the absence of any age-income relationship means that hiring managers should not discount younger MBA graduates. The data shows that earning potential is not a function of when someone completed their degree, which argues against any implicit bias toward older, more experienced candidates in MBA recruiting. Before drawing the final conclusions, it is also important to acknowledge what this data set cannot tell us. First and most fundamentally, the data is hypothetical. It was constructed for educational purposes and has not been validated against real-world labor market outcomes. Any generalizations to actual MBA salary trends would require confirmation against verified sources, such as the GMAC employment reports or the Bureau of Labor Statistics data. Second, the dataset contains no controls for the variables mostly likely to drive salary differences in practice. Industry sector, employer size, geographic market, years of pre-MBA work experience, and undergraduate field of study. Without these controls, the salary differences we observe across majors and other categories are purely descriptive and cannot be interpreted as causal. Third, The underrepresentation of economics graduates, just 38 out of 500, means that group level statistics for economics carry greater statistical uncertainty than the other four majors. Fourth, this is a cross-sectional snapshot. It captures income at one point in time, 5 years post-graduation, and cannot reveal how trajectories evolve over longer careers. Finally, all associations identified here, including the lack of an age-income relationship, are correlational only. No causal conclusions should be drawn without a more rigorous research design. So, to summarize the key takeaways from this analysis, the mean MBA income of $100,560 with a standard deviation of $23,306 reflects a healthy but variable salary landscape. Graduates can expect to approach six figures within 5 years, but outcomes differ meaningfully by major and other factors. The salary distribution is slightly right skewed, making the median of $98,180 the more reliable central measure. Economics and finance majors show a consistent but modest earnings premium over the peers, while accounting trails the group. Majors are distributed nearly equally across four of the five concentrations, supporting reliable cross-group comparisons. The scatter plot and correlation analysis confirm that age at graduation has no meaningful relationship with income 5 years out, suggesting MBA programs equalize earning potential across age groups. These findings are useful for compensation benchmarking and workforce planning, but should be applied cautiously given that the data is hypothetical and lacks control for industry, geography, and experience. Rigorous interpretation of descriptive statistics, knowing both what the numbers say and what they cannot tell us, is essential for sound business decision making. So that is the end of my presentation today. Thank you so much for listening, and those are my references. Thank you so much.